We need more time. So I can tell automatically that this is going to be way worse than normal, but hey, whatever. All right, we're back. We are COMP123 in the summer 2019 semester at Centennial, and we are Lesson 9, Part 2, which we're going to be talking about is collections as well as event handling. So I'm going to start with event handling first. And by the way, these PowerPoints are up on eCentennial for you guys. So you guys can go through them, and they're really for your review. So up until now, what's been happening is we've been using events and event handling, but we have no idea how to use them or what's happening behind the scenes of C#. So I want to quickly go through the concepts behind some simple event handling and what's happening. Now, one thing that you've been doing is you've been using something called an event, right? And really what an event is some kind of action that has been triggered in the application state. So the application's changed state somehow, right? Again, a good example of that is I've clicked on a button. Now something has happened. When I click on the button, I raise an event, and you can use the words raised, fired, or triggered when it comes to events. So I can raise an event, I can trigger an event. And a lot of times what happens when I trigger an event is I've clicked on a button, or I've dragged and dropped something, or I've entered some text. All those things can raise an event or trigger an event. And then that's happening because I'm listening for an event to occur, right? So I have an event listener, typically, and I have an event handler. Usually there's two parts to an event. And remember, we talked about this way back. Event handling is done using something called the observer pattern. Right? Now, I'm not going to go into too much detail there because that's really low level, and I'm not going to do that. But let's think about what event handling happens in C#. So we have a button, we click on the button, and we can change. When I click on this button for changing the label, we've done this little example. I change the label, and it goes from hello to goodbye. We've kind of done that together, right? And then I can also get the value of the event, the type of event, as an example, the text changed label, right? Or the mouse event args for the forms, the type of event. And we can get that because we're listening for this event. So here's an example of, on the design side, remember there's two parts. There's the code behind file, which I encourage you to modify when it comes to code. And then there's the part that I say, ooh, don't touch this file. This is the designer. You touch the designer, bad things can happen. And for now, that's true, all right? Obviously, you can touch whatever you want. You are developers. But what I'm saying is, for now, let's not fool with the designer so that the form won't break. So what's happening here is if you see this plus equals new system event handler, we're looking at the system namespace, and we're looking at the event handler class. We're passing in a reference to the event handler method that we're using to handle the change button click event. That's what we're doing. Okay? But what's really happening here? I'm passing a reference somehow into the event handler class, and yet the click event listener is getting that information. So how am I doing that? Everything okay? You guys looking around? Oh, someone's actually listening to me. Ha ha ha. Or maybe it's me talking and you guys are hearing me at the same time. That's kind of weird. Ha ha ha. I forgot to turn this off. It's my bad. This should be actually off. So otherwise you'll hear me and then you'll hear me again, right? Hey, that's okay. At least it's working. We can hear that the actual output is good, right? You're like, someone's talking. Who's talking? It's me. I'm talking, right? All right, no, this is all new for me too, guys. Let's go back. So yeah, so we've got this stuff going on here, and this is okay. But the biggest problem that we have is that we don't know what's happening in the background. So I have an event handler, and it's usually something like the control, whatever the control is that we're handling the event for, and the type of event. So for example, change button is the control, click is the event type, change button click. That's how we name it, all right? Sometimes it's known as the event receiver, and because the sender is usually the object that's sending the event. So what I'm really doing here with event handling, it doesn't matter whether you're doing it in C#, Java, JavaScript, you know, name the language, Python or whatever, or iOS, you know, as an example, or Android's Kotlin, you always have some kind of signal that's being processed. I'm sending a signal, I'm saying, hey, it triggered an event, and you're listening for something, you're receiving the signal, and you're saying, okay, I got the event, now what do you want me to do with it? Right, that's the event handler, right? So here's an example of an event handler we've seen before. We have the change button click event, and there's two parts to the parameters. We have the sender, and we also have the event args parameter, which gives you E. So sender and E. And then we have this thing, hello label.text, E toString. So one thing to note is the sender points to, or is a reference to, the object that raised the event. For example, in our case, it is the button, right? And you can have multiple senders, right, using the same event. So I can have multiple buttons sharing the same event handler, right? And then I can look at the sender object and then determine which object was the thing that sent me the signal, okay? So an example here is when you look at the sender, what object is object? Does anyone know what the object is? Anybody? What is object here in the parameter? What is this thing? You guys should have learned about this in object-oriented programming. Anybody want to take a crack at this? I can always ask people too. What's object? What does it mean? What's this object part? Okay, but where did I get object from? What is the object thing? What is this thing? It's a data type, but what is this object data type? No, you should say it's an object. Object is actually the super duper powerful class that every other object derives from. It is the parent, grandparent, mother, father, and superhero of every other class you make in C#, right? That's what it is. So when I call the object class, what I'm really saying is, this thing is an object. I don't know what it is. I don't know what type of object it is, right? But it's an object. That's what I'm doing. Someone's a generic object. I don't know what it is, the sender, but it's an object. Why am I making it this way? Because I could have many different types of senders. I can have a label, that's an object. I can have a button, that's an object. I can have the form itself, that's an object. So it could be any one of those things. So I can't cast it as a button, a label, or a form. It has to be a generic object. That's what it has to be. And that's what it's listening for. Okay? And then you have this event args parameter, which is basically what type of event has been raised. Which object is it that sent the event, and what type it is. Right? Because even though it's named change button click, it may not be the click event that you're sending. It might be sending something else. You might be communicating with a different type of event. Right? You could have one event handler that handles all types of events. Right? Not just the click event. Typically we don't do that, but if you wanted to, you could. Okay, so that's then one thing. Now we're going to talk about something called delegate. What the heck is a delegate? So what's a delegate in real life? What's a delegate in real life? Anyone know what a delegate is in real life? It's like an ambassador, right? Or it could be maybe a lawyer, right? I could have my lawyer be my delegate. Think about this, right? If I wanted to sell my house, and it was on the market, I was selling my house or my apartment or whatever, and let's say I'm away on vacation, but someone wants to buy my house. I could provide power of attorney to somebody else, my brother, father, cousin, whatever, child, and they could sell my house for me. They would be in fact my delegate, right? It's almost like a person that represents me, or a proxy. Okay, that's what it is. So a delegate is kind of the same thing in C# and in other languages. Delegates exist in C#, delegates exist in iOS, in Android, Java, as well as in other languages, right? And what delegates are representatives of another class or method or whatever. That's what they are, okay? You use the keyword delegate to designate that is a delegate, okay? Here's an example of how we use a delegate. So first, at the top, we can see the delegate keyword. Then there's the void return type. And then we have the name of the delegate class, greeting delegate. You can call this whatever you want, okay? Notice there is no greeting delegate defined here. You're defining it right now. When you make this one line, you're defining something called the greeting delegate, right? And then you have the parameter type. Right now there's only one parameter, which is a string. So we have a couple things to note here about the delegate. One is the return type, the signature of the method, void, and the type of parameters it takes, string. So we know it's the delegate, the representative of this particular, or any of the methods here, have to be able to return void and take a string parameter. We know that has to match, okay? Here are a couple of methods. Now in this case they're static because they're inside of the main method. This greeting class probably is not going to be instantiated, right? But here's the greeting program. You have this thing called hello. It returns void and takes a string. And then look, there's goodbye. It returns void and takes a string, okay? These two signatures match the delegate signature, void and a string. They must match, okay? So first I've almost made a generic name, greeting delegate, right? And then I can kind of pass one of my methods to the greeting delegate. Here's how I use it. Greeting delegate, so that's the type. We know that it's going to return void and take a string, right? First delegate and second delegate. Those are the two delegates we just made. However, they're just objects that have no body right now. We're just creating a reference to them, right? Or we actually allocating memory a little bit, right? We're saying, hey, I'm going to have this type, delegate, first delegate and second delegate are of type creating delegate. Now I instantiate two objects. One, first delegate, is a new greeting delegate of type hello. And the other one is the second delegate is a new greeting delegate of type goodbye. Notice I said of type, because there's two methods here. This method, hello method, and goodbye method. They're both compliant. They both comply with the delegate signature, right? Returns void and takes a string, okay? So I can pass either the hello method or the goodbye method as a parameter of the greeting delegate. So the greeting delegate itself acts like a constructor to construct the delegate for you. That's what it's doing, okay? And I'm storing a reference of this delegate inside these two variables right here. Okay, cool. Now we've got a little greet method down here. Greet method takes two parameters. One, a reference to the greeting delegate, as well as a string. Those two things, okay? So my greeting method, greet method, I pass in the delegate. Notice I pass in two different delegates, first delegate or second delegate. And then I pass in two strings, Kathy and Bob, okay? So what's really happening is I can use one method, greet method, to take two different instances of two different methods that can return different things. Now you're going to say, Tom, but why? Like, why this complexity? Because that's what I asked when I first saw this thing. I was like, but this doesn't make any sense. Remember that everything you learn in C# or in C++, in Java, JavaScript, whatever you learn, has been constructed for you to solve a problem. That's why these languages are made this way. What is this problem that it's solving? It's solving the whole event handling problem. I want to pass a reference to a method. The method is going to be different, but I want to structure the method to force you to use a particular signature, right? Otherwise, it can create a bug in the code somewhere, right? So what am I doing? I'm saying you must pass me something that adheres to void, return type, and string parameter, right? You must pass me this. If you don't give me those two things, I'm not going to accept it as a delegate. I'm not going to accept this as a reference. That's one reason why we use it. The other reason why is because it's generic. I can pass as many different types of methods to this as I want, right? As long as it adheres to those two things, I can pass the methods. And this is exactly what event handling is doing. All I care about is the sender and the event args. I don't care what it is, but each of the events have to adhere to that method signature. And it returns void too, by the way. So here's an example of that, right? So if I go back up, and let's take a look at that, you can see that each of the event handlers are going to return void and take two arguments, sender and event args, right? And then, if I go further back up, when I add a new event handler, the event handler is the delegate class that's taking into its constructor a reference to the method that we want to attach to the event listener. And that's what we're doing. Questions around this? I don't want to go too much deeper than this, but that's how it works. That's the back end of how this whole thing works. Okay? We're going to also be using delegates in other situations. Okay? This is not the only use of a delegate, right? But it allows flexibility, right, that we wouldn't normally have if we didn't have this structure, right? Sure, you could do this in different ways. Think about a delegate as a callback function, a classic callback function in JavaScript, right? But that's what they do. And notice the plus equal sign. The plus equal sign, what it is it allows us to add one or more event handler types. An event handler is just a delegate type, right? To the click event listener, one or more. Okay, so if I keep going down, let's go back to where we were, right? So we're here, and if you notice, the output is hello Kathy and goodbye Bob. Why? Because both of those two greetings are going to be activated, right, based on the name of the delegate that's coming in. The greeting is, and then we're going to call the delegate method, whatever the method is. This thing is going to be a reference to the method that was being passed into it, so first delegate or second delegate. And then whatever that is being passed in is the one that's going to output hello or goodbye. Okay, that's how it works. And that's really most of what I want to talk about when it comes to delegates. So again, you can assign one delegate to another using the equals operator. You can use the plus and plus equals operator to combine delegates into a composed delegate. So a good example of that is I can have more than one event handler for a single event listener. So I can have a single event, click, but I can have more than one handler handling the click event, right, of an object. Why would I want that? Sometimes I want separation of concerns. I want to do, when I click on something, I want a method to do this, and then I want this other method to do something else, right? Okay, and here's some more examples of this. I'm not going to go through too much because I want to, this actually, sorry, one more thing about this one. This actually passes something else, right? Notice it says my first delegate is plus equal to my second delegate. That's interesting. So I have a delegate, first and second, but now I'm adding another delegate to it. That's interesting. What that really means is I say that, well, my first delegate is both Kathy and Bob, if that makes any sense, right? Because look, first delegate is hello, second delegate is goodbye, right? So my first delegate is going to say hello and goodbye, whereas my second is only going to say goodbye. So this is the output. So you can see that hello and goodbye, that's my first delegate, and my second delegate is only going to say goodbye. Because they can attach more than one. That's what it is. Okay, so I'm not going to go too much more into this because again we're going to cover this at a later time. But I wanted to talk about this idea of event handling and how it works in the background by using delegates. One thing to also note is there are different kinds of events. Here are some common events that you will see in most of your controls. And a good example of this would be your click control. It's a very common one. Your enter, when you enter something, if you change the text, or you key up, or you leave a control, or you enter. There's also, going back up, if you want to do a drag and drop event, you can drag leave. So if I drag something, I pick something up, I drag it over, I exit from one control, it's a drag leave event. I enter another control, it's a drag enter event. If I let go, it's a drag and drop event. So I need 3 actual events to handle drag and drop. All right, that's how it works. Okay, so that's how drag and drop works. And there's also mouse enter, mouse hover, mouse leave, and mouse move. So if I enter a control with a mouse, I raise a mouse enter event. If I leave a control with a mouse, if I hover away from it, I have a mouse leave event. If I hover over it, it's a mouse hover event. If I move the mouse anywhere on the screen, it's a mouse move event, right? If I, mouse up when I move the mouse pointer and the button is released, right? And there's also a mouse down again, or a button click event, all right? Mouse wheel occurs when the mouse wheel moves, and a bunch of other ones. One thing to note is that some of these events don't work with everything. For example, a mouse event is not going to work with a button. It's the button events that work with the button. And a text change event is not going to work with a button or a label. It's only going to work on a text box or anywhere else you can enter text. Okay? So some events aren't viable or they don't work with every control. And there's more of them. All right. So here's an example of I want to make a click event, and notice that in our controls, I mentioned this before, you have your properties, and there's two ways you can look at the properties. One by category. This is this little button right here, and the other one by alphabetical order we talked about. There's also these two buttons. One of them is properties, and the other one is events. When I click this one, you can see that this one is now highlighted. You can see that the click event for this particular button, right, this button 1, is button 1 click. And that's what the name of the event handler is going to be when you put it in here. If I wanted to keep the same name for multiple buttons, I can highlight multiple buttons and enter the name here. And we're going to do that today in our example. Okay. All right, so there's an example of what we've already done. The click me button, we've tried that out. And there's also different mouse events, okay, which we're not going to get into. I'm just going to talk about them. You've seen them before that you know. And there's also key handler events if we want to make keyboard presses. A lot of times what we want to do when we design any kind of user interface is we make some kind of mouse events followed by or accompanied by keyboard events. We want to have both of those two things. And the reason why we want to have both is because we want to fall back. Sometimes people want to be able to do quick keyboard events when you're in a form, not just mouse events. And the reason for this, a good example is Control V and Control C. Control C for copy, Control V for paste. You don't want to go to your menu every single time and go menu, edit, menu, or menu, copy, menu, paste. You don't want to do that, right? It's too much work. Whereas Control V and Control C are keyboard events that can work for you. And there's other ones. And that's really it in a nutshell in terms of kind of a high-level view of event handling. I'm not going to talk about focus right now. We're going to learn about that later on. And one thing I want to talk about is in this video, we talked about delegates and how to use a delegate and what delegates are in reference to event handling. All right, so you understand how it works in the back end. All right, so that's really the event handling one. And I also want to talk about collections. I know that I could probably make another video here for this, but just to save some time, I'm going to go right into collection and link and what those two things are. Any questions so far? I know I'm doing some lecture stuff, and I don't like doing it. I like doing lecture lab. I like kind of doing it, and then we try it. But I need to do this part because we've already covered the how-to stuff when it comes to making events happen, button clicks and all that stuff. But you really need to understand the back-end concepts behind it as well. All right, so let's go into link and collections. This is like the next PowerPoint that I've got up there for you. So what I really want to do is talk about link and what those two things are. And link is really called the language integrated query. It's been made by Microsoft for developers. So developers way back said, hey, Microsoft, we need a language similar to SQL that makes our life easier when it comes to searching and sorting and getting information from a collection. So example would be, I want to get information from an array or a list, right? And I can use a language to get that information. Instead of me having to create sorting and searching algorithms over and over again, why not make something successful that's already there for me, right? So that's what link is, more or less, right? And it allows you to do things like filter arrays and lists and other kinds of collections. All right, so again, it's very SQL-like or SQL-like, and it uses method calls instead of quotations and a string for your query. Okay. So again, it's a declarative syntax. You're going to see how it works. And we have to use the system.link namespace for it to be active. Okay. If you don't use the system.link namespace, then you can't have access to it. Okay, curious. In this little code snippet, what do you see? You see this keyword var. What does var mean? By the way, if you think it means what JavaScript var means, you're wrong. It doesn't mean that. JavaScript var and C# var, it looks the same, but it acts a little bit differently. So first of all, what do you think it's doing here? So I have this new array of these values. So what does var do? It's taking the place of a data type. That's what it's doing. So how does it know what data type this is? What do you think? Anybody? How about you? What do you think? How do you think var works? Explain to me in your own words. Yeah. You don't know how to explain it.
What variable is?
Okay, it's not a variable. It's, remember I said it's not like JavaScript. Yes, someone put up their hand. Yes, what's var?
Somehow you're making it an object. Is it new?
Okay, we were making the object.
And that's an array. But,
It is a new array. Yeah.
because you put the square bracket, it means an array.
Okay, but how do I know what type of array it is? Yes.
Maybe it analyzes the data and then.
Yes, very good. It analyzes the data. So what it does is says, hey, what kind of structure is this? I've got this array. That's what I'm making, right? And it's kind of like saying, okay, I'm using the curly braces as a quick initializer syntax, so I can put different values in the array. Well, what kind of values are these? They're integer values. They're being stored in this new array, right? So var says, values must be an integer. It's using something called inferred. It's kind of being it's inferring, right? Type inference is what it's called. It's trying to figure out the type, or using type inference, right? By taking a look at what's being stored inside the container. So the container is storing integers, well, therefore values must be an array of integers. That's what var does. So why would I use var? Because sometimes types become very cumbersome to figure out, especially when you use more complex data structures. Right now, the data structure is really simple. You're using a lot of primitive data structures, like, for example, integers and floats, doubles, strings. Even a string is not really primitive, but most of those are structs. Also, they are. They're struct types. By the way, as we're talking about structs and classes, what's the difference between a struct and a class in C#? Anyone?
It's like a link or reference.
Struct is a link or a reference. Anyone else?
No, struct is like an object and.
Struct is like an object,
and
okay?
class